Jai Hind to all. Myself is Nikhil Kumar, faculty of IT department in Ajay Kumar Engineering College. Today I have a lecture on the Tafl. Actually, it is a lecture series in the Tafl, theory of automation and formal language. The code is the BCS 402. And in this lecture series, today we have the lecture number 4. And the topic I will discuss is that is the Arden'S theorem. That is basically the constructions of regular expressions from DFA. From the previous lectures, we have already discussed the DFA and NFA model and the language string and the basic structure of the Tafl automations. And we already discussed the minimization of the DFA models. So today we have the lectures on the Arden'S theorem. What is the requirement of this one, and what is the structures? What is the regular expressions DFA, and what is the constructions of regular expression from the DFA model? Basically, every language contains a model, okay, and the regular expressions is basically the expressions way, mathematical expressions to represent a language proper models. So regular DFA model and the regular expressions is basically not the different things that are the same, but it is the basic difference between both of them. The regular expressions contains the mathematical model to represent the model that is already discussed in the DFA or NFA models. But basically that are the machines, and to express in the mathematical term, it is represented by the regular expressions. It's know very well, already discussed in the previous lectures. So today we have discussed the Arden'S theorem. So what is Arden'S theorem? Let P and Q. We have some points that we have to be know about. Let P and Q are the two different regular expressions. So, and are also the conclusion terms to express in the regular expressions, where in this PQR basically are the regular expressions that are used to express in the mathematical term of the given automation models. Okay, where PQ are regular expressions, and P is not the epsilon, that means it does not contains the null values. Okay, so in the case of the Arden'S theorem, the statement of the Arden'S theorem is that if the P, Q are the regular expressions to represent something models, then if we can express the Arden'S theorem, the regular expression in the terms of the R equal to Q plus RP. So basically we can represent this one using the Arden'S theorem. Using the Arden'S theorem, we represent this basic structure of the regular expressions in the formation of the R equal to Q P star, where we already we already discussed that P and Q are the two different regular expressions. So basically this is the term that is mentioned in the given regular expressions in the mathematical models of the different formations of the finite automata, that is the DF and NFA, and this is the regular expressions that will be the representations of the final Arden'S theorem for the constructions of the regular expressions. So how it will be proved from this one to this one? Basically the Arden'S theorem we already discussed, that is the construction of regular expression from the DFA model. So how it will be construct? Let's suppose that is the model R equal to Q plus RP. This is the regular expressions to represent the mathematical term for the given automation model. So if we apply this value R in the right side, the resultant will be Q plus RP, Q plus RP and P. The resultant will be Q plus QP plus RP square. If we again use the value of R, that is the Q plus RP here, in the right side, the resultant will be the Q plus QP plus Q plus RP P square. What is the formation will be changed? We will discuss here that the resultant will be QP square plus RPQ. When we use the R value 2 times, replace the R value in these formations one by one again and again, the resultant will be this. So what will be the change? We will find out that the value of Q, that series is changed. Q, then first is Q, then QP, then QP square. So the resultant value will be Q plus QP plus QP square plus QP cube. It will be the resultant value. Here this value will already discuss that when we extend the value from replace the value of R in multiple time again and again, the resultant value, this one will also include in this one. So here in this given series, we can take the common value Q, then the remaining part will be the epsilon plus P square plus P cube up to N, and we can write the down, that is the P formation including epsilon, already discussed in the last previous lectures, that it is the part of the P star. We can represent, that is the Kleene theorem according to this one. So the resultant will be generated as R equal to, what is the formation was? If the formation is R equal to Q plus RP, then we can use and we can utilize this this structure into this one, R equal to QP star. So the basic content from this Arden'S theorem is that if we write down the basic terminology, basic model to express the basic model into this one, so basically we can conclude and translate, we can basically transform this transformation regular expression into this one, R equal to QP star. So what we will do now, we have some questions regarding the Arden'S theorem, and to calculate the regular expressions model from the given Turing regular machines. Okay, now here is the very first questions that we have here, A and B. So if the given question is that this is the basically a DFF or NFA model, and we have to calculate and to transform this model into the regular expression, how it possible? Basically what we will do, we calculate each state, that is a proper each state. To calculate the each state value, the first we will take the Q1. Here what we will calculate, model to, basically this question is model conversion into regular expressions, using Arden'S theorem. Basically Arden was the scientist that generated this model to conversion from the regular expressions from the given models. So we will calculate Q1, that is the state first, that is Q1 in this question particular, Q1 is the initial state and as well as the final state. We will calculate Q1 equal to, Q1 is calculated from Q2 and Q3. From the Q2 it will consider as the Q2B. We can write down Q2B. From this one it is Q1 is considered from the Q2 by the input symbol B. So we write down Q2B plus, from the Q3 it is calculated from the Q3A, because from Q3 after given the input symbol A, it goes to the Q1. So we write down Q3A, and basically it is the input state, basically the initial state. So we write down also epsilon. Same from the Q2 we will write down, we achieve the value of the Q2 state from the Q1 and the only just from the Q1 using Q1A we will write down Q1A. From the value state Q3, we will calculate from Q1 using Q1B. Okay, only from the Q1B. From the Q1B. And using the Q4, how we will calculate Q4? Using the Q4, we will calculate Q4 from the Q2 and Q3 using the Q2A plus Q3B, and as well as here is a self loop is already mentioned. So what we will do? We will calculate Q4 using Q4A plus Q4B. Basically, what we have done, we calculate each state, particular Q1, Q2, Q3, Q4 by using the principle that when we calculate the Q1, that is the initial and the final state, we will check out the Q1 state is reached by using Q2 and Q3. When Q2 comes with the input symbol A, B, it goes to the Q1. So we will calculate Q2 followed by the B plus Q3 followed by the A. So we write down this one. Basically, it is the initial state. So we write down plus epsilon. In the other case, we only use that term that is mentioned in the given questions model. So the what next we will do? We will calculate the Q1 representations for the output state. To calculate the Q1, that is the final state, what we can do, we will check here that Q2 and Q3 is mentioned in this equation. So what we will do, we use Q2 and Q3 terms and place these value Q2 and Q3 in the equation number 1. Put value Q2 and Q3 in equation 1. So the resultant will be the Q1 equal to Q1A. For the Q3, the value is the Q1B, and we use the A plus epsilon. That is the resultant value. Here, what we will can do here, Q1 we can take the common value Q1, and the resultant will be the AB plus BA plus epsilon. We also write down in this way Q1 AB plus B. We only replace here the position of that one. So that what will be the next value of this one? Using the Arden'S theorem, as per the rule given, what will be the resultant will affect here? What is the Arden'S theorem? If we use the regular expressions, the given model into the regular expressions in the formation of Arden'S theorem, what say? Arden'S theorem. If we write down R equal to Q plus RP, if this is the basic principle, if we write down the given model into this expression R equal to Q plus RP, where P is not the null epsilons, so we can write down this regular expression into R equal to QP star. That is the basic Arden'S theorems. So using the Arden'S theorem, what we will do, the Q1 resultant value will be epsilon AB plus BA star. Here epsilon does not contains any possible any value will not affect this structure. So the resultant value will be the AB plus BA star. So this will be the resultant regular expressions for the given models. We can transform this model to this regular expression by the using of the Arden'S theorem. This is the very basic questions for the Arden'S theorem, we have a next questions that also contains the that also use the Arden'S theorem. The question is that is the Q1, Q2 and Q3. It is a self loop, contains 1, 0, 1, 0. Here is a self loop 1. And what will be the next? It is a given model, and yes, it is the given model, regular expressions. Basically, it is the finite automata, and we will calculate the regular expression for the given models. So what we will do here, we basically calculate each state individually, and then will summarize the resultant value of the regular expressions. So firstly, the Q1 will be calculated as from the Q3 0 plus Q1 0 plus epsilon, and Q2 is Q2 1 plus Q1 1 plus Q3 1, and the Q3 resultant value will be calculated from this one. The Q3 is calculated from the Q2 0. So this is the expressions. So what we will do here, we will place this Q3 value in these equations, then we will check what we will do next. Put Q3, and what is the objective of these questions is to calculate the regular expressions model from the given questions, and the resultant will be expressed in the formation of the Q1, because Q1 contains the final state. So the put Q3 value into Q2, or equation number 1, into equation number 1. Q2 equal to Q2 1 plus Q1 1 plus Q2 0 1. Okay. So what we will do next, we take the common. Here we can write down Q1 1 plus Q2 from this one, and this one we will take the common value Q2 1 plus K0 1. Okay. Using the Arden'S theorem, as we already discussed, using Arden'S theorem, basically it is very important to write down what we will using in these questions, and any question we in this question we using the Arden'S theorem. So we will write down using Arden'S theorem, and also contains the mathematical expressions that is used in the Arden'S theorem. Using Arden'S theorem, if R equal to Q plus RP, then R equal to QP star. It is mandatory to write down. Q2 will be Q11 1 plus 0 1 star. Okay. So what we will do next, we will write down Q1 and use put the value of this one into this one. Put Q3 value in equation number 2. What will be the next? Q1 equal to Q3 0 plus Q1 0 plus epsilon. This is the equation number 2, and the resultant will be Q2 0 0 plus Q1 0 plus epsilon. So what will be the next? Q1 equal to, the Q2 is replaced here, Q2 is used here. So we also write down, this is the equation number 3. Put Q2 value from equation 3, in Q1. The resultant will be Q2 0 0, that is the here Q11 1 plus 0 1 plus 0 1 and the star, that is the Q1 value, Q3 values. Okay, what we will do, we will replace the value here. So the resultant will be Q1 1 plus 0, okay, 0 0 plus Q1 0 plus epsilon. So we can write down this one in the formation of, we will use epsilon in the starting way to calculate proper in the these formations as per the given Arden'S theorem. Epsilon, here what we will do, we will take the common value Q1 1 plus 0 1 star 0 0 plus 0. Okay, so this is the basic formations of the Arden'S theorem. How it possible? Look at this one. If R equal to Q plus RP, okay, when we will compare, the resultant value will be effect that R is here is the Q1, okay, and Q is the epsilon, and P contains this one value, common value. So the resultant will be, using Arden'S theorem, we will write Q1 equal to epsilon 1 plus 0 1 star 0 0 plus 0 and star. It is also write down that here epsilon does not contain any value, affecting value. So the resultant will be 1 plus 0 1 star 0 0 plus 0. This is the Q1, that is the final state, regular expressions to express from the given model. So what we will do, we take the two examples to verify and to calculate the Arden'S, to calculate the final regular expressions from the given model using the Arden'S theorem. So in these lectures, we understood the Arden'S theorem, the proof of Arden'S theorem, and the applications of the Arden'S theorem apply on the two questions. So this is the resultant value. So hope so you will understand the Arden'S theorem and the resultant, how to calculate the regular expression from the given Arden'S theorem. In the next lectures of the DSTL lecture series, we will take the next topic. Thank you.